Ultimately, coronavirus patients succumb to the disease when the immune system is overactivated and they suffer from respiratory failure. My lab routinely studies the way the immune system deals with cancer. We develop tools to limit the extent of immune cell activation. We've been working on this platform for several years now, and by chance, we can utilize this platform specifically to corona patients who develop a severe disease. Current therapies for corona patients are mainly to deal with symptoms. None of them actually target the pathology of the disease. We're providing novel tools with a unique system to target the pathology and thereby limit the deterioration of the disease and not just manage the symptoms. What we are doing is cutting-edge technology, and we are several steps ahead of our competition in the world.
We are working on the immune system, exploring the role of different white blood cells and how they deal with different pathogens, including bacteria and viruses. In the context of the coronavirus, we're trying to find where the virus is hiding during the incubation time. One of the mysterious things with this virus is that there is a quite long incubation time, and during this incubation time, the virus is hiding and still not clear in which tissue in the body, in which cells in the body the virus is hiding. And finding this will allow us to maybe start the treatment earlier and detect the virus in a more efficient way. And in the second project that we are performing, we are trying to understand how the receptors that allow viral entry to the cells are being regulated.
My lab is focusing in immunology, more specifically the antiviral immunity. We are focusing on specific cells, which call T cells, and these cells are the most important cells to attack and kill viruses. Recently, we found that these cells are highly sensitive to lack of oxygen. We found that this is an obstacle, and in this situation, the cells cannot operate normally. Now we're actually taking all our findings and we're trying to take them forward in order to manipulate the T cells and the immune system in hypoxic condition, in lack of oxygen conditions, such as in the coronavirus. And this is give us a huge advantage in understanding how to manipulate the immune system to make it better against the coronavirus infection.